lagged variables. A possible source of any problem with the functional form is the lack of a lagged structure in the model. One way of overcoming autocorrelation is to add a lag dependent variable to the model. Now, suppose there is an autocorrelation in the series. So what you can do, you can use the lagged dependent variable. So automatically this autocorrelation will reduce. If it does not reduce, add a second lagged variable. However, although lagged variables can produce a better function form, we need theoretical reasons for including them. Inertia of dependent variable. Inertia, whereby a change in an explanatory variable does not immediately affect the dependent variable. The overreaction to the news, particularly common in assets markets, often referred to as overshooting, where the assets overshoots its long-run equilibrium position before moving backward to equilibrium. Say sometimes the news comes, suddenly government issues some policy and it is helpful to the banking sector. The banking shares will shoot up. Then automatically, slowly, it will come down. To allow the model to produce dynamic forecast. Types of lags. Auto-regressive refers to the lags in dependent variable. Distributed lag refers to the lags of explanatory variables. Moving average refers to the lags in the error term, as we have discussed in ARIMA or ARMA. Potential problems with the lag variables. The main problem is deciding how many lags to include in a model. Sometimes hit and try. Sometimes the system helps. The use of lagged dependent variables can produce some econometric problems. If you go on using the lags for dependent variables, say I'm using yt minus 1, yt minus 2, yt minus 3. So this may create econometric problems. How many past lags are affecting the present value? With the number of lags, there can be problems of multi-collinearity between the lags. There can be difficulties with interpreting the coefficients on lags and offering a theoretical reason for their inclusion. Why so many lags are being taken, or why the lags is taken. So theoretically, we'll have to see that. This data is from 1991 to 2018 for 20 years. I have taken up the Gujarat GDP, and then capital expenditure by Gujarat and social sector expenditure by Gujarat. So I am just, because Gujarat GDP, I'm just going to write it here as GDP, so that when I work on Eviews, I need not write more things. Here, capital expenditure, I can write simply CAP, and social sector expenditure, I can simply write SS. It will help me. So now I can load this data, this 28 years data for Gujarat. I will load it on Eviews. Eviews file, the data is there. So year-wise, GDP, CAP, SS. So I'll go to next, and then I'll go to next. Okay, finish. So I have created this CAP, GDP, SS, and there are years. The first thing is, let us open this data, whether this data we have opened it rightly or not. Control and press GDP, then control, press CAP, and then SS. Okay, and I'm going to open it as open as group. Okay, this is what is there. Now, first of all, let us do the quick estimation. Because I so use VAR to see the lecture. So GDP, CAP, SS. I'm just going to say okay, and this is given me the VAR. VAR means there are endogenous variables. CAP is affecting GDP, GDP is affecting SS, and all below. Now I can go to view. I can go to lag structure. I can go to lag length criteria. So this is not, so it, if I use 6.1, so it tells me that I should use 6 lags in this case, because you see the dotted lines. AIC criteria says 6, SIC criteria says 6, and Hannon-Quinn criteria says 6. And thank you. May submit your research work at Journal of Global Economy, rcssindia.org. Your work is evaluated by peers with double-blind methodology. You will get comments for your work.